Hello, and welcome back to Teacher Gimble's channel. Today we're going to be going over Illustrative Math, Geometry, Unit 1, Lesson 2, Constructing Patterns. Let's get started. Problem 1. This diagram was created starting with points A and B and using only a straight edge and a compass to construct the rest. All steps of the construction are visible. Describe precisely the straight edge and compass moves required to construct the line CD in this diagram. So we're trying to identify what did it take to draw CD in this diagram. So when you see these overlapping circles like this, something that you should start getting used to is thinking about the radius of each circle. Now I'm going to highlight just circle B. Now the reason I'm calling him circle B is because the center is B. And that's the way that I'm going to refer to circles from now on. If we notice, we have circle B and we have this radius right here. And that's our circle B. That's pretty easy to see once we've highlighted it. Now we are also going to create circle A. Circle A has the same radius as circle B. You see, if I highlight in blue and I have the radius of circle A, I can create the same size circle. So when I'm creating a diagram like this, the first thing I do is I create segment AB. I'm going to create circle B with the radius of AB and center B. Then I'm going to create circle A with the same radius AB with center A, and I get these overlapping circles. Once I can have these overlapping circles, I have these intersections, which I call C and D, and I draw a line intersecting both of these points, and that is how I got constructed line segment CD. And that's it. And we're going to see this construction several times in the lessons going forward. So if you need a second to pause this or re-go over what I just did, feel free to do it as I move on to the next question. Problem 2. In the construction A, the center of one of the circles, and A is the center of one of the circles. So A is the center. We're just going to call it circle A because it's easier to see when we have colors. So if you have a workbook, I recommend pulling out your highlighters right now, or colored pencils. I like the pink better. B is the center of the other. So we have the center of B right here. So we have two circles, and if you notice, we actually have that same construction as we saw in problem 1, where they share the same radius, because the radius of circle B is that guy over here, and the radius of circle A is actually the same line right there. We need to identify all segments that have the same length as segment AB. So we need to figure out all of the segments. Let's get started. AB, we've already highlighted. So I'm going to actually undo what I just did with the blue, or with the pink. I apologize. And I am only looking at circle A. So with circle A, I see that I have this radius, and I'm going to go thicker so you kind of ignore all the extra lines. And that's my circle A. I know any line segment that has the same radius is going to be congruent to AB. So I see this is a radius of the same circle, AC. I see this is a radius of the same circle, AD, and I'm going to put lines on top because they are segments. And I see this is a segment of the same circle, or the radius of the same circle. And I know their radiuses because they go directly from the center to the edge, EA. Because they are all radiuses of the same circle, I know that they are congruent, or have the same length. Let's go on, and we're going to calculate the same thing, only looking at circle B. It deleted all my answers. Okay, we'll have to just erase. So circle B, we have the center over here, we have the radius over there, and we're going to draw circle B nice and thick. And I'm going to do the same thing. I'm looking for all of the radiuses, because I know if AB is a radius, any other radius that I have is also going to be the same length. So So I find CB, I find segment B. This dude doesn't have a name, so we're not going to call him anything. And I find BD. And I'm done. I found all of the segments that are the same length as AB. Now let's go ahead and circle our answer. A is a correct answer. B is a correct answer. And remember that AC and CA are the same segments because when we're looking at a segment, we can trace it this way or we could trace it that way. So it's the same thing. We have segment AE, which is going to be the same as EA, because EA or AE traces the same segment. BC is the same as CB, so that is one of our answers. We are going to have to erase, I don't want to erase. We're going to have to erase these dudes and scroll down. And we see CD. I don't see any CD here, so I'm going to cross out answer D. And DE. I don't see DE as one of my answers, so I'm going to cross them out as well. So in that way, we found all of the segments that are congruent, or I keep on using the word congruent because it means the same length to AB. If you're not used to the word congruent, it's a word that you should start getting used to now because you're going to start seeing it a lot throughout the geometry lesson. All right, let's zoom out a little bit so we can get all the answers on the same page. The diagram was constructed with a straight edge and a compass tools. A is the center of one circle, and BC is the center of the other. Select all the line segments that must have the same length as segment AB. So I'm looking at my circle over here, and I'm seeing that AB is a radius. So I find myself another radius right over here, and I say, AC has to be the same length as AB. Now, I'm looking at my other segments, and I'm thinking, is there anything else that I know must have the same length? Well, circle C does not have the same radius as circle A, so I know that that can't be an answer. BD looks like it could be the same length, but I don't actually have any proof that it's the same length, so I'm not going to put BD as part of my answers. So AB, we know is the same length. Well, AB has to be the same length as AB because it's the same segment. AC is the same length because it's a radius. BC, we're going to cross out. BD, we're going to cross out. And CD is a radius of the smaller circle, but it's a different radius. We're going to cross out. And we're done. Let's go on to the next question. Problem 4. Claire used a compass to make a circle with a radius the same length as segment AB. So we have a circle here, and we know the radius, which I'm just going to highlight, is the same length as segment AB. There's a special way we mark this in geometry. The way we do that is we mark it with the same dash through it. And because our dashes match, we know that they're the same length. She labeled center C. Which statement must be true? Well, let's look at our statements. Must AB be equal to CD? We don't know anything about CD, so we can't say if that's true or not. Must AB be equal to CE? CE goes from here all the way out. So no, that's also not true. Must AB be equal to CF? Well, we have our segment that we said is the same as the radius. So yes, this looks like it's correct. But we always check all of our answer choices. D. Is AB equal to EF? AB, we don't know if it's equal to EF, so we cross it out. We're finished with this lesson. If you like this lesson here, please like and subscribe to my videos, and so you can keep getting them. I hope you enjoyed, and I will see you next time.